I think let's start. People are getting late, but let's start and we will resume from where we were. You will recall we had seen this behavioral model of a my circuit, which we were talking about, and we had said that there is an error because a output cannot be used as an input, and therefore we had worked on the solution. And the solution was declaring a temporary signal xtemp, and rather than assigning the value to x, we assigned to xtemp and then used xtemp as input variable in this condition checking, and then finally xtemp value is assigned to the signal x, which is the primary output. Now, please note that signals can only be defined in the architecture before the beginning. Okay, so this is the only place. And general rule, I did say earlier also, try to include all the signals which you are using on input side, because your process has to be having all of them in the sensitivity list. Now, this is the second kind of architectural description, another way of describing. Now, this is known as data flow model. Data flow model makes use of no process statement. It will have all concurrent statements, and that is most suited for your hardware description. That is the best way of describing any hardware if you can, and this directly is synthesizable with a good synthesis result. Now see, if you are doing it in data flow model, what you will have, again you will declare a signal xtemp. Okay, now you are saying xtemp takes the value of when a, or a is transferred to xtemp when s is equal to 0, else b. Okay, so this is the kind of conditional assignment statement. Okay, similarly the second signal y is assigned the value 1 when temp is equal to 0 and s is equal to 0, else 0. Okay, so again, this is a conditional signal assignment statement, and then you utilize this temporary signal to transfer x. So you'll see just 3 signal assignment statement and your model is complete. And how the data flows, you get to know it. Now you will also see, okay, I'll come to timing a bit later. Now there are two things. So far we talked about only signals, but there is one more entity which is called variables. The variables also can be utilized to assign values, and variables can only be used in a behavioral code. So signals follow the notion of event scheduling. Now, event is what? Event is characterized by a time and a value pair. What does it mean? That at so and so time, what value to be assigned. Now, variables do not have a notion of time, and variables get updated immediately. So for example, if I say x gets the value of xtemp, it means that schedule the value of xtemp to signal x at time instant, which is current time, plus delta time, because here I have not specified any time in the statement, so my default time will be delta. Now what is delta? Delta is a infinitesimal small unit of time, or it is the minimum unit of time which is used by the simulator, VHDL simulator, for processing the signals, because signals have to be scheduled, and as the statements come in time, they have to be scheduled. We will talk about it more a bit later. Now, what are variables? Variables, I said they do not have notion of event, they don't have notion of time. variables cannot be defined and used only inside the, can be only defined in the process which appears in behavioral code. So variables will only appear in behavioral code, not in data flow code and not in structural code. Okay. So this is the place where you declare the variables before begin within the process. You remember signals were assigned even before the process started. It was just after the architecture statement. Variables will be defined within a process and can be used within a process. See, this is variable assignment statement. Sorry. See the operator. This operator is used for variable assignment, whereas this was the operator which was used for signal assignment. So by operator, you know whether your destination is a variable or a signal. So if you try to use the different symbol, it will give you an error. Okay, this I have already said to you. And then what you do is when you do simulation, you are modeling the output response of the circuit to the given input stimuli. So what you will give a input vector and you will try to see what happens on the output. Okay, so for here, you will give the values to ABS and you will observe or determine the values of or monitor the values of X and Y. There are many kind of simulators. You can have a event. See, saying the only this key, I am unable to understand you. I don't understand what you have not understand. You have to speak out and ask a question. What have you not understood? Please see, understand that VHDL could be a 40 lecture course and I do not have 40 lectures to take and teach the VHDL course. So I did tell you the book, kindly go through the book. It is only syntax and semantics. So I don't intend to discuss all the syntax and semantics in the class. Okay, I am going to give you only an overview which should help you learn yourself and try to learn yourself and come out with the doubts. And if there is any specific question, I am ready to answer. But saying so, okay, I don't understand from slide will not help. There are two types of primarily used simulators. We are going to use a model sim for this, our application. So this is kind of example which I am not going to go further. I'll go into some details of basically the VHDL. Okay, I'm sharing another screen and I hope the second screen is available now. And yes. Yeah, so I just I'm covering some more details on VHDL and I will send this tutorial. This is a tutorial which we had prepared while I was in Siri, while teaching VHDL to our colleagues and students. But even this was something like 25 lecture module. So which I cannot do everything in the class. Okay, but you should be aware of it, and there is just one unit within the course which should not take me more than, or doesn't allow me to take more than 5 lectures or so. So I cannot do everything, the whole book within 5 lectures. Okay, and that is why I'm using PPT so that I can be a little bit faster, else I'll keep writing and wasting a lot of time. Basically, design units are a piece of code which can be simulated in VHDL. we talked about two design units, a entity and a architecture. We said entity is one which describes the interface, IO ports, and architecture defines the behavior of that internals of that circuit, whichever we have defined. And these together make the definition of that particular design component, whatever you are doing. But at times it is not enough to be done through entity and architecture. You need to have many more things within your kind of design. Just give me a second. I'm getting a sorry for the interruption. So in addition to these two design units, there are three more design units. And these units I am not describing in detail, but just a brief think a package declaration, a package body, and a configuration declaration. These are three more units. Now, for example, you will recall I said you can define your own types, data types. Okay, so if you are trying to define them, you will make a package declaration and you will define it over here. Okay, say any kind of a global thing you can define over here. You can even design or make your functions, and you can make your functions and define the functions over here, and the body of the function will appear in a package body. Okay, so these two units are useful to make the your own library of components. If you are trying to make, you can make the library of your functions, library of your type definitions, subtypes, and many more things. And all of them can be stored over here, and they can be simulated. Okay, and design configuration declaration is used to supply the tagging like entity and architecture binding. Okay, you can because this binding is also mandatory. Either you need to do it binding through your configuration declaration, or you have to do binding through your configuration specification statement. So once we start taking one or two examples, you will understand it better. But kindly just try to understand what are the main things. It is something like similar to what you do any programming language, but with some little bit changes because it is concurrent in nature. This is how it looks like. So when you are doing a system modeling using VHDL, okay, now this we have talked about, but I still repeat, VHDL provides a rich set of concurrent statements to model the concurrency in digital hardware. So the execution of concurrent statement is triggered by events on one or more of its input signals to which it is sensitive, which is called the sensitivity list or sensitivity channels. Okay, so there is a language semantic which requires that simulation time should not be advanced until all the concurrent statements whose sensitivity channels have had events at a current time have been processed. What does it mean is, in the code, let me check out. Let's say if you have these many concurrent statements, the current concurrent statement may be processed with a sensitivity list, It could be a signal assignment statement, maybe 0 when and A is equal to this, or B is equal to 1 or something like that. Or there could be another concurrent statement of the kind block. There are variety, I'll talk. So this has a signal list, which is sensitivity list. This also X has few signals within it. They may have event. Even this could be maybe Y or Z or some variable, some signal. Okay, so if there is a event here, here, or here, this statement gets triggered. So this has to be assigned, this process has to be done, this block also happens simultaneously. So in the time unit, if this is my current time t, all these things have to execute, only then I will move ahead in time. So whenever you say this assignment, this, if there was no time construct within it, it is at delta. So it is x plus delta time over here, where this change will occur and x will change. So if block had somewhere x as the sensitivity element, so this block has to re-execute over here. Whenever there is an event, all of this has to execute. All the concurrent statements have to get executed at a given instant of time wherever there is an event on sensitivity channel. Okay, that is what it is meant. This is what is, again I repeat, delta delay is the concept. It's only a notional delay concept. So notional delay does not advance the time unit as such. If I was at 3 nanosecond time instant, this will become 3 plus delta. Okay, and this is only to support a simulation which is zero delay simulation, and it also with a cause of sequentiality, maintaining the sequentiality and still having a notion of time, because all the things in concurrent simulation are triggered by the events. So you have to schedule events, and events, when they occur, they trigger the next event. Okay, so I'll tell you, I'll take a code and I'll explain to you what does it mean. This also takes care of the stability of sequential circuit elements. And I repeat, current simulation time is not advanced. It is only a delta time which is added. Okay, so what you are doing is you are starting a simulation, you update your signal, they will schedule events. So model will be evaluated, time will be incremented, signals will be updated, and this will continue happening till you reach the end of the simulation. I think we'll start doing it for some small combinational circuits. But before that, what are the statements available? Now see, these are the various concurrent statements available in VHDL. Now this, this is used in behavioral code. This is used in behavioral description, a process statement. This block statement is used again typically in a data flow model. It can be used even in a structural model. Then you have concurrent assertion statements. I'll go to these statements briefly. Then you have a concurrent procedure call in a data flow description. You can have concurrent signal assignment statement, which is used in data flow. I had shown you. Then you can have component instantiation statement, which is used in structural, which I have not talked so far. And then there is a generate statement, which also is used in the structural. So these two primarily will occur in structural. These two you will see in data flow, and this can be used anywhere. This is used in behavioral code, and this also can be used at multiple locations. We will talk about it where and how. I think I'll leave this. So I'll come to some constructs. Okay. Now this is a multiplexer. So we will talk about the behavioral modeling of this multiplexer. So this multiplexer, when I'm talking of behavioral modeling, means I will use a process statement. Okay, so let's see how will I write. And process statement within it itself will have the sequential statements. See, so definition of, first you will define this unit, which is entity. So entity keyword followed by a user defined name. Since it is a 4:1 mux, the name given over here by user is mux_4. I write all the 4 inputs and the 2 select lines, which are of type bit. So this is mode and this is data type bit. And there is one output Z out, mode is out, and type is bit again. Okay, end of it. So I have completed the IO port. Now when I come to the architecture, I am writing behavioral architecture. So the name given is BEH. You can have any name which you like. Of which entity? So you have to write the entity name, and then you start beginning. That means I don't want to define any signal, any temporary signal to be used. So I am not declaring it. So process statement has to be sensitive on all the inputs. So all the 6 inputs are over here. So what will happen now? These if is a sequential statement, and it is same as if else if what you use in C. So if this is the condition, S1 and S0 are 0, 0, then Z takes the value of in 1. Else if this combination, this value, this combination, this value, else, that means it is only the 4th combination. So in 4, this is end of if statement and end of process and end of the behavior. Okay, so here we have used just one concurrent statement, which is process statement, and within process statement we have just one sequential statement, which is if, else if, then. Okay, if, else if, or whatever you call it, if then else, or whatever statement you call it. Now we need to talk about what are the types, operators and objects in VHDL. Some detailing, because this is a strongly typed language. VHDL is known to be strongly typed language. What does it mean is there are a lot of predefined types and you can have user defined types. So every object has to have a type. Okay, and if it has to have a type, only the same type objects can be assigned to each other. I cannot assign a value of integer to a bit. That means I need a function to convert a integer to bit value or a bit value to integer value. I have to write those functions. So see some of the predefined types or subtypes. I did mention Boolean, bit, character. Now character is what? Any alphanumeric character which is in ASCII code can be converted. Then there is a predefined type which is severity level, which is warning, error, And there is one more. I'll tell you. There are none. One is yeah, a note. Then there is a warning, error, and failure. Four type of severity levels are there. We will use, and I'll tell you. Integer, natural, positive, real. These are some of the numeric values. Okay, and then time. Time means a numeric value followed by a unit. Okay, so time is also a predefined type over here. Then you have delay length, string, bit vector, file, open kind, file open status. Even these are predefined types. And there are many more types. And you can see in the book, and you can refer to the book by Jairam Bhaskar. The PDF has already been circulated to the entire class. And if somebody has not got it, please contact your CRs and get it. It has been circulated. There are other books which you can use. One is Douglas Perry, and another is Ashendon. But I recommend use either this or this. This is more exhaustive, so don't refer to this. And student version is available for Ashendon, which is a short handbook type that can be referred to. Okay, so these two soft copies are available. If you have not received, you can contact. I can even circulate again. That is not an issue. Now there are different operations on values of specific types which are defined with the help of function declarations and definitions. So the language provides you a set of predefined operators for predefined types. Now what does it mean? For example, for predefined operators could be something like add, subtract, multiply. There are logical operators. I'll come to it, what all operators are there. First, let me describe what are the objects available. So there are only four kind of objects which are available in VHDL. One, we have talked about signal. So object, this is basically known as object classes. So these are four classes of objects. So anything which you define is an object, it will have a class of one of the four types. So either that item will be signal, or it can be variable, or it can be a constant. For example, if I said 0 within the code, so it was constant value I was talking about. Okay. So, and the fourth type is file. I am not telling you to use file right now. First, let's start making some small codes. File we will come to and use when we start simulating for a big data. So we will use file for the storage of bit vectors or large number of bit vectors. Prior to it, we are not using file. Now, see, these are the three classes of objects. So these objects have to have some kind of data type. Now, when I define a signal A or B, X or Y, I have to say what kind of data or what data type it is. So types again can be classified into four types: scalar type, composite type, access type, and file type. So right now we are not talking about file type and access type. We will only talk about scalar and composite. Scalar means just holding one value. And one value means one set. Even time is scalar. When you say 3 nanosecond, so it is, I believe it is scalar. We'll check it out though. And composite are two types, which are arrays and records. So array means, for example, when you make a matrix, you have a one-dimensional or two-dimensional or multi-dimensional matrix can be defined, which where every element is of the same type. Okay. A record could be something like, if I store a record in my assessment file which contains a roll number, name of the student, then MST mark, EST mark, and maybe finally a sessionals and then a grade. So this will become a record where roll number is some natural number value. The name is not alphanumeric, it is only alphabetic. And then marks, maybe EST, MST are integer type or real number type. They might not be even integer, they might be real values. And then you have a grade, which is again enumerate type, A minus, B minus, or something like that. Okay, so this becomes a record, which is a set of values, but the types of all the elements is not the same. Okay. Now in scalar, you can have these different varieties. One is integer type, which we said we know all what is integer. Floating point is decimal, the values which contain the decimal. We can define the various formats. Physical type is the like time, 3 nanosecond or something, that is physical. Any physical quantity which has a value and a unit. So you can define the physical type and you can use it. Predefined type is only time. Then enumeration is, for example, Boolean. Boolean is enumerate type where the values are true, false. Okay. I can have another enumeration type for my tri-state logic, and I say my tri-state logic is 0, 1, Z. Okay, so this will be enumeration which has a predefined set of discrete values. And the values can be of any type. Now see, this is enumerate type, which I said here. There is one type which has been declared, 3-level logic. But here 3-level logic is what values? X, 0, 1. And then I can declare a object A as in class a signal, and it is having a type, data type is 3-level logic. You can declare another enumerate type color. Okay, and I can define my 3 primary colors, maybe green, yellow, and red. So I can use a variable which is light, which is of the type color, and I can utilize this variable as one of the 3 values. It can change between that. Okay. Now, this is what is the primary strength of the VHDL. These kind of enumerate types cannot be declared in Verilog. And you will see the strength of these declarations when you write the code, when we start writing it. See, integer type declarations, some of the type declarations could be, now word length. I know my word length is going to be 32-bit. So I define is range 31 down to 0. So whenever I declare a signal to be of type word length, okay, it will be 32-bit. I can also declare subtype within this. So see, now I'm declaring a subtype which is data word, and it is subtype of word length. Word length was 32 down to 0, but this is only range 15 down to 0. Okay, so it is a subset or a smaller version of word length. it is having similar thing, but the range is different. So if I want to declare something, a new subtype of a different width, I can declare it as a subtype. Now I can declare my data, which is a signal, to be of type word length, which means now it will have a 16-bit value. Okay. And see here, a variable index is used just as an integer, and integer is a predefined my type. Okay. And integer, what is the integer range will depend upon my processor. So if I'm using a 64-bit processor, my range is from 2 to the power minus 2 to the power 64 to minus plus 2 to the power 63. Okay, so that is how you can work out. See, floating point types. See, real data is range 0.0 to 20.0. Okay, so now you can define it with one decimal, one place after the decimal, and then this variable width, see, uses this is another way of defining the subrange. One way is you declare a subtype and use it. This is another way that you define over here only while you are declaring the variable, you say what the range it is going to use. So you can limit the range while in declaration also. Okay, and many a times we do this rather than declaring all subtypes. But for example, if I am doing a data path unit and I have 20, 50 kind of register and processing elements, and all of them are 8-bit wide, let's say. And every time I'm declaring a signal of type range 7 down to 0, 7 down to 0. So rather than writing that, I declare it once, a subtype, and use it n number of times. That is the idea. See, another declaration, temperature, which is because temperature we will measure in real values having one decimal place. So I'm using here real, 1 or 2 or whatever you want, you can do it. This is one example of predefined physical type, time. Okay, so it is already defined. Type time is range. This is the range in which your number appears. And units are femtosecond. And then there are so many units which are defined and their equivalence is already defined. So you can use in your simulation any time unit, FS, PS, NS, microsecond, millisecond, second, minute, hour. All of them have been defined and in relation to one other. So in a progressive manner, the smallest unit first and then you advance. So any time unit less than FS, we will not be able to simulate because you can see femtosecond is the smallest time given. If I want a time unit of the power minus 18, I cannot because my time here is integer followed by minimum femtosecond. So I have to have a integer value at least 1. Okay. If I wanted that, I will have to declare another time unit with smaller values, or maybe rather than using integer, I can use here a real number varying between 0 to 1 or something like that, and then you use use it as a mantissa, and then you use power or something like that. Composite, I did mention there are of two types, array and record. I will only do up to array and record and then I'll stop. So array is homogeneous composite type. That means it has an element of arrays that are all of the same type. And then records are heterogeneous type. You may have two elements of the same type or you may not have, but there is at least there are two different kind of types involved in all the elements which you use within a record. These are some of the examples of array. What we defined bit array is actually bit vector is also an array. So it is array of bits. You can use it for address, you can use it for assigning a vector or anything of that kind. You can see here the bit vector is array of natural range of bit. This is the predefined type. Okay, but if you can limit what is the range you want for bit vector by writing it within the bracket while you are declaring a variable or a signal, that time you can limit the range. Otherwise, whatever is the natural range in your processor, that will be taken as the maximum range. Now see, if you write here variable accumulator bit vector, this is not accepted and it is illegal to write because it is unconstrained and you must limit what is the bit vector length. So you always have to define it. This will be circulated to you. This as such the whole PDF I will send it to you. This is how do you declare a record type. So register bank is being declared. It has four entries. F0 and F1 are of type real, R0 and R1 are of the type integer. So there are four elements within this type. See the value being assigned to a object of type register. One, this is real, the two values are integer. You assign all of them together. You can assign one single value by attaching a dot to a particular element here, and you can assign the value or you can assign the whole record. Both the options are available. Okay, I think I'll stop over here and we will continue to do something more on VHDL, and then I'll take up some example how do you write, and I'll show you different models, and then I'll ask you to do it yourself and simulate. I'll request my tutors to tell you how to download the software and get started in the lab classes. Anything which I can answer at this point in time? Else I'm closing the class over here. Let's meet in the next class on Monday.